Good, wonderful. Then I'm just starting directly. Yeah, thank you for the nice welcome. I want to talk a little bit about the reference and calibration measuring devices which are currently available for hydrogen refueling stations, with a focus, of course, on the German, Austrian, and Netherlands area, which is in the moment our main task. So, what kind of terms I'm using, of course? Calibration and standardization should be quite clear. Yeah, we have a comparison of a measurement value which can be delivered by a device. In my case, in my special case, it's a kind of hydrogen refueling station. Under the test with another calibration standard system. We have reference devices, which is then the referred device for the calibration. In Germany, we are also dealing with local authorities, standardization authorities. We call it Eichbehörden. This is usually a local responsible authority, which is in charge for witnessing this test and confirming the final certificate. Calibration on site is the process itself, which is done on the refueling station itself. The accuracy class is maximum allowed deviation between the value of the HRS in comparison with this reference device. What we have as a kind of special in Germany is a comparative measurement check, which I simplified explained. It's a kind of measurement check we are doing for all stations to confirm that they are quite okay, but they will not get a real official certificate. So what I'm talking about is a hydrogen refueling station. Hydrogen refueling station, just a simple process. We have a kind of hydrogen storage area here on the left side. This is kind of tubes. We have a technical conversion of this hydrogen in form of a compressor, which is compressing the gas, which is stored usually at around 200 bar in the station. Then it's going to be compressed up to 700, 800, 900 bar, depending on the station type. And then finally, we are dispensing it into a fuel cell car or a fuel cell truck. So any fuel cell vehicle is possible with a kind of, we call it dispensing unit, which is also quite similar like this one on the right side in the picture. So now the main question, what we are talking about. How to be sure that, for example, 4 kilograms, which I sold there, which are dispensed on the dispenser, how can we be sure that these 4 kilograms are really 4 kilograms in the vehicle tank, which is then finally paid by the customer? And this, of course, is done by this calibration and reference check. So just some basic input. How do we measure this, the hydrogen on site? We have a classical system. It's a classical measurement technology. It's a Coriolis mass flow device. You see it here in this example of a Refuelling mass flow device. There are several other companies like Tricor or Chem also delivering similar systems. You have an electronic device which is calculating a kind of frequency change of a banded tube. You see it here in the middle. This banded tube has a kind of standard frequency, and as soon as there comes a mass flow through this banded tube, the frequency is changed. You spend some forces on this banded tube, and these differences you can calculate and measure, and you finally get with some calculations the mass flow in a simplified way, in a simplified manner now. This has to be ensured that this is correct. This is the basic for all. If this is not correct, then you can not trust your measurement. There is some legal thing behind this, which is also applicable all over Germany. Germany will not be Germany if we don't have a legal thing for this. Here are just some pictures of this nice legal laws I'm fighting with the last 12 months already. To say it in German, Gesetz über das Inverkehrbringen und die Bereitstellung von Messprinzipien auf dem Markt, ihre Verwendung und Eichung sowie aus Fertigpackungen. Totally terrible law, just the name is already totally strange. I don't want to bother you with this one. The short summary of this law is quite clear. You have to do an initial verification with the commissioning of the station. So if a supplier of a machine is commissioning the station and he wants to hand it over to operation, he has to make an initial verification. So he has to prove it on first that the station is okay, that it's measuring correct. And he has to do a repetitive verification every 2 years. This has to be done by the owner of the station, by the one who is operating it finally. Yeah? This 2 years certification can be interrupted by a special inspection. For example, if you're working in a kind of maintenance on a flow meter, then you have to do another repetitive verification also after 1 year maybe, because of course you're changing the principle of the system. So how do we measure this now? It's quite easy going. We take a weight scale, take a tank, put some hydrogen in the tank, put the tank on the weight scale. It's not so easy. Some companies used to have a kind of scientific approach for this so-called gravimetric method. They have very nice scales. I will show some pictures soon. But it's not so easy like we think. The scale is very precise. They have a scale resolution of 0.1 gram. Some have a 0.2 gram. And they have an uncertainty budget of 0.25%, which is a very good resolution for such a system. But the challenges of all the systems are the tank, the weight of the tank, this complete system itself, condensate, ice, temperature, all these things. So, who was working on this in the last 12 months? There are a few companies which are working on these topics or which have provided now a kind of system. For example, Air Liquide in France, the Metas Institute of Switzerland. There are some stationary systems of Linde Company, some other mobile systems in California and Japan, which look like this. This, for example, is a reference gravimetric measuring device of Air Liquide. You see already the size, it's a complete trailer. You have a nitrogen bottle next to it because you need to flush and purge the system. You have a kind of construction site fencing around the station. This is a special regulative of Shell company. You're blocking a part of the station. One lane of this dispenser is blocked, it's not accessible. And furthermore, inside the system, they all look quite similar. You have a kind of tank. In this case, for example, it's a meter system. It was also public. You have a kind of tank, which is consisting of a few devices like valves, pressure, manometer, etc. It's enhoused in a kind of housing for atmospheric control. You see this tank is located on a big scale, which is there in the middle of the picture. And the process itself is easy going. You measure the empty tank, you fill the tank, you measure the full tank. Of course, there are some slightly special things. You have to kind of waiting periods, you have purge periods, etc. The whole process itself takes 1 hour for one measurement. But the system is more or less everywhere the same. If we go on an international basic, this is a reference measuring system of the California Department for Food and Agriculture. They developed this system a little bit further. They're already using 2 tanks, so they can make 2 fillings with 1 test. It's quite interesting, but so within 1 hour you can do 2 measurements, but it's still not really a nice system. Also, the car is not, if you look strictly to the car, this pickup truck, it's not really stabilized on the ground. So every wind shaking influences the weight scale already. Then, of course, the Japanese, I'm sorry for the bad pictures I have from Japan. They included already, I think, 4 tanks in their truck. The truck itself has a kind of hydraulic lag system, which can stabilize the truck against wind influence. So they are already on a better way. What do we have to achieve? the regulative for this is the OEML 139. The OEML 139 says that for hydrogen, you see it left below, we have to achieve an accuracy class 2, which means that the final error allowance is around 2%. Especially for Germany, we were fighting for the hydrogen class 4, also the accuracy class 4. This is especially for old stations. You know, we have around 95 stations in Germany. These 95 stations, many of them are kind of prototypes. They are very old. Some of them are now 11, 12 years old. And they will not match the class 2, but they will match class 4. But anyway, they will never get a certificate because in this OEML 139, there are also some additional challenges. Yeah, you have to provide a kind of error code. You have to provide a special type of software. You have to provide a special size type of cashier system. Yeah, and so on and so on. Also by the construction, many of these old stations will not fulfill this measuring system diagram, which is there on the right side, yeah, which is also provided in the OEML 139, yeah, because they just have a simple technical other approach of the things. They were prototypes for refueling. They do not work like this. They work in a different way. The meter is somewhere else, something like this. So they will never have an official certified. This is what we are doing. This is then that we do a final check on site. You are just providing this is class 4, but they will never get an official certificate for this metering. Anyways, this is accepted by the German authorities. So in a summary, until now we used to have a kind of scientific research on this topic, and the challenges which we are approaching as from our company in question of an economical efficiency are quite clear. We have with this measuring devices which are existing on the market, we have a long time required, up to 4 days for a measurement campaign. We have a downtime of the HRS or the dispenser, because sometimes we cannot use the HRS for refueling customers anymore because it's just blocked. This makes it all expensive. We need a lot of auxiliary media like nitrogen for purging. We have hydrogen losses because everything what we are filling in the tank has to get lost again afterwards for the next measurement. There are only a few actors on the market. We have a long term of directives we have to fulfill: pressure vessel directive, explosion protection directive, etc. And also this meteorological dependence because of possible ice formation, and the non-comp filling was an issue for us, which makes this current measurements very precise and very exactly, but they are not economical efficient. So our goal was to have a kind of our own reference device project, which should be able to make one calibration check within 4 hours. It should be possible that the HRS remains available. We wanted to have a kind of inline flow measurement, that we are not losing the hydrogen. We didn't want it to need any auxiliary media. We wanted to have no components which has to be checked regularly. We wanted to be weather independent, and we wanted to use the infrared communication. And to show all this in one picture, we came here to this point where we are in winter in Ingolstadt and measuring with our reference device the first test campaign. You see the 2 little boxes in the middle in front of the dispenser. One box is the metering itself, the electronic device. The other one is the flow meter, the Coriolis mass flow meter. This device is now a system which is quite stable. We have now the proof for class 4, definitely. For class 2, we are awaiting it by the end of November. And we are also doing currently the certification transfer process to Austria, Netherlands, Denmark. Also other European countries are possible. This is according to the European law, quite easy. The point is that we do not see a market there at the moment. There are just no stations. So this is then a process which is coming up afterwards. As a further outlook, yeah, this system what we have is also possible to be extended to 350 bar, and we can also extend it to other flows, so to much higher flow rates with several connection kits. This is the next step which we are approaching in 2022 or 2023. So successfully now we used to have the first calibration in Germany. This was done by the end of October. It was not officially announced yet. There will be a press release for this within the next few weeks. This successful calibration now 3 weeks ago. You see here the picture of these guys which are all there down at the station. There are only 3 technicians. All the other people are somewhere from the PTB or from the local authorities. They were all interested in it because it was the first one. Yeah, in the background of the dispenser, you see slightly the trailer of Air Liquide. It's positioned on the other side of the dispenser. Front left side of the dispenser, you see our system, which was also certified in this process. And this is now an announcement, which is really the hottest news here, which will come next, I think 2 or 3 weeks. There will be the official press release. So this was a short call because I was stopped to be in 15 minutes. Paul, was this quick enough?
Yeah, that's great. Thank you, Stefan.